Okay, here we're told the Mach number and temperature upstream of shock wave are 2 and 7 degrees Celsius respectively. So let's draw a shock wave. Flows going this way. We call this 1 and 2 upstream and downstream of the shock. So we know the Mach number at 1 is equal to 2 and the temperature at 1 is 7 degrees C. We should convert that over to Kelvin. So 7 degrees C is what, 280 Kelvin? Okay. And what we're asked to find is what's the airspeed relative to the shock wave downstream of the shock wave. So we have our downstream conditions, and what I want to do is find the velocity downstream here relative to the speed of the shock wave. Now, currently we're in a frame of reference where we're kind of standing on the shock wave, right? So we're moving with the shock wave itself. So we're trying to find the airspeed relative to that shock wave. Right? Not relative to the ground, but relative to the shock. So what we're really trying to find is just the velocity at 2 downstream here. So this is pretty straightforward. What we're going to do is find the Mach number just downstream of the shock. That's a function of the Mach number upstream. This comes from the normal shock relations. This function, well, let me just go ahead and write it out here, but it looks like this. You can either plug the numbers into this formula, or you could use the normal shock tables on at the back of a textbook or in the formula sheet. But we know the Mach number upstream, right? That's equal to 2. We can calculate the Mach number downstream. So Mach number downstream comes out to be 0.58 subsonic, as we expect. And then what I want to do is get the velocity downstream. So I'm going to find the velocity by using the definition of the Mach number. So the Mach number at 2 is the velocity at 2 over the speed of sound at 2, where the speed of sound at 2 is the square root of kRt for an ideal gas. So I need to find the temperature at 2. And to do that, there are different ways to do it. One way to do it is to simply use the normal shock relations to find that. So T2 over T1 is also a function of the Mach number upstream from the normal shock relations. And to get that, I don't remember what that one is off the top of my head. Let me just go to the formula sheet. I know it's in here somewhere. Apologize for having you watch me scroll through all this. We'll find it eventually. I must have passed it by. This must be entertaining for you to watch me scroll through here to try to find the formula sheet. And I'm going back and forth. You've probably seen, there it is. Okay, so T2 over T1 is this expression. Okay, so I'm not going to write that down, but you get the idea. You can plug in the Mach number at 1, and you can get T2 over T1. Okay, so let's go back to our problem. So from this, we can get T2 over T1, and if we know T2 over T1, we can then calculate what T2 is. Because we know T1, right? We should use the absolute temperature of 280 Kelvin. So if you do that calculation, that comes out to be 473 Kelvin. You can see that the temperature goes up across the shock wave, right? So the temperature went from 280 Kelvin to 473 Kelvin, so it went up. Now that we have that temperature, we can plug it back in here to get the speed of sound. And then once we have the speed of sound and we know the Mach number at 2, right? We have the Mach number at 2 there. We can calculate the velocity at 2. And that comes out to be 252 meters per second. So that's just one way we can calculate this. Oh, by the way, some other numbers I used in here is the specific heat ratio for air is 1.4 and the gas constant for air is 287 joules per kilogram Kelvin. So those numbers were used down in here as well as up here. So that's just one way that we could calculate the speed V2. Now keep in mind this is the velocity of this stream relative to the shock wave. It's not the velocity relative to the ground. It's the velocity relative to the shock wave. There's another way we could get V2. For example, you could also do V2 over V1 from the normal shock relations. That's also a function of Mach number 1. And then if you have that, you can find V1 from the Mach number upstream and the temperature upstream. Because V1 would be Mach number 1 times speed of sound 1. Speed of sound is just kRT1. We know the Mach number at 1. That's right there. And then we know the temperature at 1. That's 280 Kelvin. So we could get V1 from that and then use this expression to get V2. And just to show you again, since I found the formula sheet there. So V2 over V1 is right here, right there. Or that's actually V1 over V2, but you get the idea. So that's just an alternate way that you could have done that calculation. So there are different ways you could do it, but you'll end up with the same velocity ultimately. All right, that's all there is to this example, so we'll end there.